Okay. Hello Halifax. It's good to be back. I was actually here 6 years ago at Atlantic Security Conference 2013. So it's grown a bit bigger since then, but absolutely happy to be back. Here today to talk to you about bug hunting, or what I have learned from doing bug hunting for a long time. There's really only two parts. First I'm going to talk about bug hunting, then I'm going to rant a bit about disclosure, and we'll finish off with a conclusion. Now a little bit about myself. I'm a former developer, turned sysadmin, turned pen tester. Right now I'm a full-time security researcher. I'm in the software labs of Zenith Labs, which is part of Dark Matter. We're hiring, by the way. We're not on that spreadsheet, but if you go on our website, there's about 70 roles, including some here in Canada. So you have a look at that. I should say also that the company is relatively young, far less than a decade, and specifically, I guess in this case, I should prefix that the views and opinions presented are my own and not necessarily that of the company. So with that out of the way, let's talk about bug hunting. Now specifically when I say bug hunting, I'm really interested in bugs that results in vulnerabilities. So, you know, what is it? Well, the vulnerabilities basically. I don't care for QA bugs, anything like that. Where do I look for vulnerabilities? Specifically for me, it tends to be software, but obviously vulnerabilities can be found anywhere, ranging from security locks, airport security, IoT, software, hardware, crypto wallets, like Colin showed yesterday. So you can find vulnerabilities absolutely everywhere, and basically every system has an opportunity to have its security posture strengthened. Why would you look for vulnerabilities? That all varies depending on who you are. Some people look at it, look for it because they want a challenge. Some people look for it because they want to improve their understanding of security. Some people look at it for profit. Some people look at it for fun. And some people really want to improve the security posture of the internet or software computing industry in general. How do you look for vulnerabilities? That is a very non-specific question and answer. Essentially, because vulnerabilities can exist everywhere, there isn't a specific straight-up answer to that. If there was a very procedural way of detecting vulnerabilities, we simply wouldn't have software vulnerabilities anymore. That'll all be eliminated with one swift run this program, no more vulnerabilities. Generically, everyone in this room, they all come from different technology background. They have different levels of knowledge, technology experience, expertise, and you can apply that in different ways. And as such, there really isn't a cookie cutter approach. Sure, you can use tools to find some vulnerabilities, but I think uniquely, what you do is you start with what you know, and then you look for problems in that space. If you try to look for vulnerabilities in a completely different space, you'll often be hindered by the fact that you're learning the new technology more so than actually finding vulnerabilities. So, but let's say you decide, okay, I'm going to go ahead, I'm going to look for some vulnerabilities because I think this would be a great thing to do. I generally always recommend with reading the documentation, getting an understanding of what the technology is, what it does, what are some expected behavior, unexpected behavior. A lot of times you'll find footnotes or even just straight up poor examples in the documentation. When I was here 6 years ago, I was talking about security problems in payment gateways. And universally across all the payment gateways I was looking at and presenting at the time, they all had the same design flaw, which I assumed came from copying a previous implementation, and it sort of eventually spread and became the standard. But that was something that I identified simply by reading the documentation, and here's a design flaw that you can't easily patch out of existence. So that's a very good place to start, very valuable. And then you've got to learn to recognize weakness patterns, or sort of, critically think about what you're reading, whether or not it makes sense, whether or not there are corner cases that they didn't think of. And once you're done with that, you can move on to actually test the problems. You learn to, once you've done this for a while, you learn to anticipate the types of mistakes that developers will make, such as checking for authorization, or checking for authentication rather than authorization. So you get privilege escalation vulnerabilities. And the other thing that's, I think, very important is once you find something, or you've had an idea, you read the documentation and thought, but what if that assertion or the assumption that this function, always returns true is wrong? So it's very often good to challenge the status quo. Be curious, as Cliff said in the keynote yesterday. And feel free to write a test script to test your theories. Don't just assume that the documentation is right, or assume that the framework you're using is without flaws on its own. Now, once you get started with bug hunting, it can be very overwhelming. You're consuming a large volume of information, and then you might not be too specifically experienced with a large number of vulnerability classes, etc. I generally say there's a couple of things you do to simplify it. And the first one is to start off by learning specific bug classes. So you might say, well, this week I'm going to learn SQL injection, or this week I'm going to learn buffer overflows, or this week I'm going to learn some other vulnerability. You can hop on ExploitDB. You can find software that is vulnerable to the bug class you want to learn. You can download the exploit. You can download the vulnerable application, and then you can see what they actually did. But better yet, you can try to discover it yourself. So from installing blank piece of software, finding the vulnerability, writing your own exploit, it's a very good learning curve. And then I generally say that once you have one, you then build on it. So you learn one bug class, 2, 3, 4, 5, and expands out. And then as you're reviewing software, generally it's better to start focusing on specific vulnerabilities at the time, until you get familiar with the software, and at that point you can start looking for more things. And it certainly avoids things. If you're dealing with web, I generally never look for cross-site scripting, because those things just show up everywhere. So you can always come back to the software later, even if it's like 2 or 3 years later. You can still come back to the same piece of software. And if you find something new, you can check if the latest version is vulnerable, which they often are, or you can just report a bug in the old version, for that matter. So generally, when you find a vulnerability, what you want to do with it is you want to report it. So whether it's to the vendor or whether or not you're going through something like a search, that's kind of up to you. But I generally find that my enthusiasm for software vulnerability kind of follows this curve here, which is, it's kind of flat. I've got an idea or a concept or something that I want to test. Then when I have some free time, I start looking at that problem, looking at that software, and I usually find something that's tangible. I'm like, this might be a vulnerability, and you dig deeper, you build on it, and suddenly you have something that you can leverage to achieve higher privileges, code execution. And at that point you got an exploit, you're popping shell, and it really feels good. Like, especially if it's a tricky vulnerability, you might have spent a whole week building up to that exploit, and then you've overcome something. It's a personal achievement, and it feels good. And then at that point you generally start to write up the technical details. Maybe in some cases you keep piling more bugs on top to see if you can go from authenticated code execution to unauthenticated code execution, but eventually you consider it done, and then you start writing up the advisory. You write up specifics of what you did, etc. And I don't know about you, but even as a pen tester, report writing wasn't my favorite part of the job. Writing advisories is usually a lot easier. They're very short and sweet, but they're still not as fun. So sort of my enthusiasm declines. Then you got to hunt around the internet to try to find the security contact details for the vendor. You email the vendor, they may or may not respond. There's some emails going back and forth, and eventually the advisory gets released. And my sort of depression starts to go back up because I'm done with it and I can start breathing again. And this is a very non-linear timescale of this problem, because essentially the first three panels, the discovery, validation, and exploitation, it's usually a pretty quick process. I've been doing this for a while, so it usually doesn't take me that long to write an exploit. So let's compress that down to say about a week. And then the disclosure portion typically drags on from 1 month to multiple years. So it actually looks very different in reality than sort of what you see here. And of course, one of the other problems with the fact that the disclosure drags on for so long is that as you find more vulnerabilities, this thing doesn't scale. So I had a friend in Melbourne who just tweeted the other day that so far in 2019, he has gotten over 100 CVEs assigned. And if each one of those is to a different vendor, and each one of those drags on for 4 years, he's got a lot of time to invest in emailing vendors and trying to follow up on getting a patch fixed. It sort of, he does this on his own spare time, and obviously it eats into basically all the free time that he has. If he continues at the rate that he's doing now, and he finds 300, 400 vulnerabilities by the end of the year, that email chain or email workload is huge. So anyway, so when you are reporting vulnerabilities, there's a couple of things you should know. The first one is, what do you report? You got to write up a technical, accurate description of the vulnerability or vulnerabilities that you've found. I generally say a section per vulnerability. Even if your exploit is chaining them all together, each problem that needs to be addressed by the developer needs to get its own specific section. So you describe the technical problem, you describe the impact of exploitation, you describe any technical limitations such as this require authentication, or you need a non-default configuration setting, you include your CVSS score. I generally don't try to tell vendors how to fix the problems in their software. I might give them a reference link, but I generally leave it up to them to choose how they're going to mitigate the problem, because a lot of the time mitigations aren't just use parameterized queries or whatever the security industry tend to repeat as a mantra. Very often you can solve security problems in other ways as well. Now, where to report it? That's the hardest part most of the time. Like established vendors, and particularly in the later years where we've got bug bounty programs, it's gotten a lot easier to explain or to work out where do you need to send this information to help the vendor get it patched. But even so, a lot of smaller vendors, they have no experience receiving vulnerability reports. They don't publish information. And so there's a couple of things I usually look for. The first one is domain name of vendor /security. That was defined in RFC 3013, I think. But specifically, the people who wrote that RFC said it was only for ISPs. So most people don't have /security. In the recent years, a new standard emerged, which is security.txt. It's like a robots.txt for websites, but with security information. I'll look for that, secondly. If they don't have that, I'll often Google, just go Google vendor name and vulnerability notification. And a lot of the big players, they do have vulnerability notification pages. They just don't live where you think that they would, but Google have them indexed, so you can find them there anyway. Now, if all of those fail, I generally email a generic email address like support@vendor.com, and then I'll CC in abuse at hostmaster at postmaster at security at, like all the old RFC email addresses, and basically ask for security contact. Now, hopefully they come back and you get a security contact and you can progress on with that information. And at that point, it's usually time to obtain a vulnerability tracker or vulnerability ID. Most people are familiar with CVEs. CVEs, you can just go to MITRE. They have an online web form. You fill in the details. You click submit. and you should get a CVE, or they will pass it on to the certificate numbering authority. If a vendor has the right to issue their own CVEs, like Microsoft or Google, they'll pass it on to those details. And if you don't want to do that, OpenWall has a web form where you just click a button and you get a unique generic ID, and you can use it without having to go through any of the hoops that getting a CVE requires. Right, so that really takes care of finding the vulnerabilities, telling the vendor about the vulnerabilities, and waiting for a patch. Once the patch is out, we typically go through with something called disclosure, which means that we make the details of the vulnerability public. These days, I'd say there's 5 different types of vulnerabilities. 5 different types of disclosure. The first one is no disclosure, which is where the researcher will find a vulnerability and choose not to notify the vendor, whether that means they just sit on the vulnerability to come back and look at the software a bit more in detail later, whether they sell it on the black market or sell it to a private exploit acquisition program. It doesn't matter. The vendor doesn't get notified, and it's unlikely to get patched. Private disclosure is what we generally, as I consider bug bounty programs to be this time around. The vendor gets notification by the researcher. Usually there's a reward. Nobody tells the user, it just gets quietly patched. Sometimes the vendor will choose to make it public, but that tends to shift it away from private disclosure to coordinated disclosure, because as soon as you actually make the details of the vulnerability public, you're engaged in disclosure as opposed to keeping it private. Coordinated disclosure, that's the one that we see the most. It's when a vendor gets an email from a security researcher, there's a bit of back and forth, a patch gets produced, a public disclosure gets sent to like BugTrack or released alongside the software, and then hopefully the users will apply the patch, which is, I guess, the primary purpose of the disclosure. Full disclosure is typically when the vendor gets notified when the researcher makes the information public. So there's no prior notification to the vendor. The researcher makes the thing public, and that's it. And then the last one, which is pretty new, is the notion of alternative disclosure. And probably the most known case of that was the St. Jude MedSec short selling form of disclosure. I don't know if we'll see specifically too much of this, but I think people in general will look at alternative ways of doing disclosure because they're unhappy with the current status quo, or they're looking to make money. All right. Now, some might say I didn't see responsible disclosure up on that slide. I really dislike the word responsible disclosure. I used to say it, but the industry as a whole has moved away from it. MITRE no longer says it, Microsoft no longer says it, Cisco. I only know a few people that really stick to the notion of proclaiming that responsible disclosure. But one of the reasons, well, I guess there's 2 main reasons why I dislike it. The first one is that traditionally it was used by vendors to make security researchers not go public. So Microsoft, for example, I mean, they're good now, but in the old days they used to not fix vulnerabilities, and then they'd threaten the security researcher with, oh, you're not being responsible, you can't make this public because we haven't patched the vulnerability. And I don't think it's on the security researcher's responsibility to make sure that patches get, secure code gets produced in the first place, which would have prevented the vulnerability, or B, gets patched in a timely manner. So that's the first reason why I dislike responsible disclosure. The second reason why I dislike responsible disclosure as a term is that no matter how you do disclosure, some users or some data will always be compromised as a result. I just generally, I much prefer coordinated. Coordinated basically says, we spoke with the vendor, and there's no ethical or superiority attached to it. It's not less valuable than saying responsible. So if you can take anything away from today, please start using coordinated. All right. Now, the industry does tend to get hung up on the disclosure debate. It rages fiercely every couple of years on social media. I really think we should not worry about it. I don't think that the disclosure debate is particularly meaningful to improving security, and I'll get to that through a number of these slides. Particularly though, some of the problems that I see with the disclosure debate is vulnerability tourism. So a lot of the people that are very vocal on social media about disclosure, they don't work in security. They don't send vulnerability notifications to vendors. They don't receive them from a vendor perspective. They might just be the IT guy who had to stay back on Thursday and make sure they applied the patches. And now he's online and he's angry about it. So they generally don't add significant value to the discussion to begin with. There's a mute button. Use it liberally. I generally say don't engage because it's not driving the debate at all. I think it's much better to deal with vendors who have to deal with it from their side, and security researchers have to deal with it from their side, and they can have a meaningful discussion. The other thing that I see a lot is this, I call them strawman arguments. Think of the users. You have to make sure that the users stay secure. This also harkens back to a lot of the notion of responsible disclosure. The truth is that what keeps users secure is secure code development practices in the first place, reducing the amount of attack surface vulnerabilities in the software that users use. But in this case, we're talking about disclosure, so we're assuming that something slipped past that stage. So once there is a vulnerability, the security researcher didn't place the vulnerability there, they just found it. And it won't go away whether or not the security researchers disclose or don't disclose. The vulnerability is there until it's patched. So no matter how you do disclosure, the thing that's going to keep users safe is patching. And we can argue about disclosure all we want, and you could say that disclosure has some meaningful impact on patch adoption, and I will agree. But I think it's very small, and I'll back that up with some data later on. We see a lot of shallow arguments, similar to the fact that users think of the users. One of the ones I see a lot is, you should include proof of concept exploits in your advisories. And again, I feel that usually comes from someone who's not well informed. Because the thing is, once you apply a patch, you might have to reboot. You might have just patched it on drive, not in memory. The patch might be faulty, or the patch might be trivial to bypass. Like I think it was Cisco who recently published a patch that consisted of just blocking curl as a user agent. That's trivial to bypass. It's not solving the underlying problem. And some companies have a long-standing history of only patching the proof of concept that was provided by a researcher rather than fixing the underlying flaw. And so by providing a proof of concept, and not necessarily a fully weaponized exploit, but at least a proof of concept in your advisory, the sysadmins who supplied the patch, they can test whether or not the patch was effective. They can look for similar problems elsewhere in the source code or the application, and they can also check whether or not potentially the patch was flawed. So I think it's very valuable for defenders to receive proof of concepts. And again, you might argue that there is a link between proof of concept and exploits used in the wild, but I'll come back to that one as well in another slide. And it's not necessarily. I'll actually talk about it in assumptions. The assumption often is that once there's a patch available, the problem is done. Right? We've moved past it, and hopefully everyone applies the patch. The truth is that bad guys often wait for the patch to arrive and then reverse it and derive exploits from that, or even look for similar problems elsewhere in the source in the application that hasn't been patched. And we know from the past there's been several cases in Windows where Patch Tuesday comes along, and immediately the day after, someone has found the exact same parsing problem in, say, the PNG library, exists in 4 other functions, so now they have 4 free OA because the patch got released. So it's not a non-tangible problem. I also see a lot of assumptions around the fact that, like, oh, it's patched in SVN, right? PHP was terrible with that. And I still see it with some of the vendors I deal with today. They'll say, oh, we don't want you to disclose until the end of the month the patches in Git. And I give you're open source. Git is public. Anyone can go look at that. They can reverse the patch and write an exploit. And if you don't want me to release an advisory to help drive your users to apply the patch, they don't need my advisory to determine, like the bad guys who are looking for ways to exploit software, they don't need my advisory to write an exploit. They're good at what they do. They know where to look for it. So they will look at change logs. They'll go to GitHub and they'll search for security patch and get literally the last 1,000 security patches applied over all the repositories in GitHub, and then they can cherry pick what they want to attack. So this other part that goes between the time between patch being available and release of the disclosure, and a lot of vendors think that you should delay that by 1 or 2 weeks or whatever to allow patch adoption. And I would argue that unless you have very rapid automatic patching, it doesn't matter. As soon as the patch is available, the bad guys are on the clock. So, and of course, we have no empirical data. We have no way of knowing what gets disclosed with a proof of concept that will get adopted and exploited in the wild by the bad guys. People can release 0 days on Twitter and they never get exploited in the wild. And then someone comes along with an old vulnerability, writes a worm, and it gets exploited everywhere. And we have no way of predicting, let alone just even tracking what is being used where. So part of the problem with the disclosure debate is we don't really have data to make informed decisions. And last time we talked about disclosure policy compliance as a problem, and not so much a problem with the debate, but being very inflexible with the disclosure policy, I would consider harmful at times. We've seen in the past cases where the vendor gets 0 days dropped on them because they failed to provide the security researcher with PGP keys, right? And the researcher has a policy that says we will only provide vulnerability details over PGP because it's sensitive data and someone could steal it from plain text and put users at risk, whatever. I think that in general, each vulnerability, each scope of attack, each impact, each vendor, each specific case, they're all different. I also don't think that if you have a 90-day hardline on disclosure, if you find that the patch is available after a week, or even that the vulnerability is being actively exploited in the wild, I don't think it's useful to wait for 90 days to notify users of the potential problem. So again, it's I don't proclaim to have the answer to these things, but I think that we possibly need to rethink the core problems that we want to discuss or with the current disclosure. So also, please don't do this. This is an Aussie guy. I know him. I absolutely expected better from him. Don't harass security researchers. Security researchers, they're trying to help. The bad guys, they don't go and disclose that they exploited something. You never get to yell at them, right? So he's yelling at a guy who's trying to help. And the other thing he's doing, he's not yelling at the vendor. So in this specific case, it was a vendor who had exposed all the customer databases on the internet, no credentials. Cameras on the internet, no credentials. This thing was in showdown. And at this point, whether or not it's in showdown, bad guys either mine showdown or they scan for it themselves. The people who want to steal this data, they've already stolen it. And he's not yelling at the vendor for just putting all of the data out there without authentication. He's yelling at the guy who's trying to help the vendor fix the problem. So yeah, just please don't do that. All right, some of my own personal stories about disclosure. try to speed this up a bit. I'll probably go over, just so you know. All right, dealing with vendors, this is a non-scientific pie chart, just based on sort of my gut feeling. 75%, most of the time when I deal with a vendor, they're very good. You know, I send them an email, they reply, we agree on sort of they produce a patch, I disclose, no hard feelings. They're usually very, very good and very easy to deal with. Even if they've never seen the vulnerability report before, very rarely have I had bad experiences. In the undefined section, it's often vendors that are no longer in business, so I never got to deal with them. You know, we just end up disclosing the vulnerability, and so it's not really a bad story. It's not really a good story. It's just well, we don't really know what dealing with that vendor would have been like. I've also done a number of different disclosure methods. I've gone through certs before. I've done direct. I've done full disclosure. I've done bug bounties. They all tend to be the same. The one thing I'd say about going through a cert is they're usually good as well. They're usually you know, they're there to help. The one thing that I feel like they do though is they tend to just shuffle emails back and forth, and it tends to add to your volume of email as opposed to dealing with the vendor directly. But if you are concerned about, you know, a vendor turning around and trying to sue you for finding a vulnerability in their product, which we all know happens, going through a cert can be a useful way of dealing with that. So in my experience, disclosure tends to fall in one of the two streams. One is I contact the vendor, I say, hey, I got some information, how would you like to receive it? They respond, I send them the details, we email back and forth. Sometimes most often the patch comes first and then the disclosure, but sometimes they take forever, or they change their mind and say, we're not going to patch this, whatever, then the advisory comes first, and public pressure tends to make them rethink, and the patch becomes second. The other one is when you email the vendor, and you never get a response, and then you just release the details. That tends to be the two paths. As discussed earlier, there are other ways of dealing with it, but I've had very good results with one of these two. But I will talk about some of the bugs I've been involved with that were very non-linear or very non-straightforward. So the Cacti Superlinks plugin. Cacti is a network monitoring tool. They had a plugin for dealing with links, not that I noticed, but in June in 2014, somebody published an exploit, SQL injection exploit on ExploitDB. A few months later, I'm on a pen test. I come across the same software, the same plugin. I independently find the SQL injection, and then when I get back to the office next week, I install the software and I determine that it's actually not just an SQL injection, it's a very trivial remote code execution. So I contact the vendor. We kind of lost the dates. They've deleted the website, so I wasn't able to recover it. But the vendor, anyway, they come back and they go like, yeah, it's fixed in SVN. And I come back a bit later to check, and SVN is not public, and the download is still serving the old vulnerable code. So I open another ticket, crickets. And then I kind of go, well, you know, if they can't be helped, I give up on escalating. But I come back a bit later to check. It turns out they still haven't fixed it. So I escalate again on social media. I actually release the exploit because the way I see it, they've already had the initial exploit available on public ExploitDB for 6 months. And anyone who actually looked at that source code would have typically drawn the same conclusion as me, that it's not just SQL injection, it's a remote code execution. This is very likely to be exploited in the wild by this stage. I mean, it's been public for 6 months. So I release my exploit, and I include my proposed patch so that, you know, users can patch their own systems. Nothing happens. They still serve the vulnerable code. And then I've kind of just given up on it, and I went back and I looked through the timeline before giving this presentation. As it turns out, in 2016, basically 2 years later, they added the plugin functionality into the core of the application in GitHub. And then 6 months after that, they released the official version that now contained the plugin in the core, but it's also, it's patched, so it's no longer vulnerable. So that's great. That's almost 3 years after the initial disclosure. Then I have a patched version in the core, but the website hasn't been updated. It still shows the old version available for download. Eventually a year or so after this, they go and they update the website, indicate it's now in core, blah, blah, blah. The old download link is still there. It's still vulnerable. If you run the old version of the software, or you try to install the plugin over the top of this, you might end up still being vulnerable. So, and they never disclosed anything to their users in terms of, there's a vulnerability in this. They just incorporated it into the core functionality and quietly patched it. So that was one experience. I have a lot of these, but specifically I'm talking about two. PHP, Mongo admin, the same thing. A bit later, 2015, the exploit becomes available for sale on Leap Day, which is another exploit database. About 2 weeks later, somebody opens an issue on the developer's GitHub saying, hey, here's a vulnerability. Could you please patch this? I run your software. I don't want to be at risk. And then nothing happens. Crickets for 3 months, and some random person chimes in with a whole bunch of stuff that's not relevant, but they have opinions. A month after that, the developer comes on and sort of is like, yeah, but this isn't a problem. The exploit called system function in PHP, and you can just disable the system function. And so I'm looking at it this time, I jump on the GitHub and I'm like, well, see, the problem is that they chose to call system, but they could call pass-through, or they can do any number of other things. You can't just go patching or on the basis that if you just do this one config change, you wouldn't be vulnerable, because that's not understanding what the problem here is. A bunch of other people also joined in on that GitHub, and eventually, the developer turns around and says, okay, yeah, all right, I understand, I admit this is actually a problem. Now, who wants to patch this? Apparently he doesn't intend to patch it. So he's asking the community for a patch, and I guess that's fair enough, but no one comes forward to submit a patch. So 1 year later, this thing has now been publicly exploitable for 2 years. He finally submits a patch, and he closes the issue. And I remember looking at that patch going, this looks like the wrong approach for solving this problem. But, I didn't have time, so I ended up not looking at it. And then while later on, I'm working on some material for training. I'm like, this would be, I think, a good use case to look at patching not being done correctly. So I come back to look at it. Turns out the developer has reverted the code back to the original vulnerable code, presumably because he made a mistake in the patching, and the patching broke something. And it's still there today. It's still serving the vulnerable code. He still has there's no updates on his website. There's nothing, he's closing issues on the GitHub. I guess he doesn't care. So this thing's been, publicly exploitable for 4 years, and anyone who downloads this gets a free unauthenticated remote code execution from the internet as soon as they deploy it. It's great. So those are my stories. I mean, there's only some of the stories. Not every story is bad, but it also proves this notion that vendors don't necessarily care to fix the security flaws in their product. They don't necessarily care about the security of their users, even though they have a public statement about we take security of our users and that personal data very seriously, blah, 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 which I'll probably repeat if they ever get breached. But deep down, a lot of them, they just want to write their software or live their life or, do whatever. So let's look at some of the very famous cases. Hopefully you all know these three that I'm going to go through. We get shell shock. Now, shell shock is it's a very curious example. This one followed what people would have called responsible disclosure, or I call coordinated disclosure. In September, the initial bash environment variable vulnerability was reported, and then they decided on roughly a 2-week patch cycle. So 24th of September, the patch release date was scheduled for. All the distributions got notifications. They were all ready to stand by. The patch released, and I think it was a couple of hours later, they eventually released the public disclosure. They'd done good triage. They've identified all these different ways they could have been exploited, etc. All very good. But unfortunately, it was such a trivial vulnerability to make a worm or write an exploit for that it would literally take someone with skills 5 minutes to write a function and exploit, and then you depend on the entire internet to go and apply the patches from whichever Linux distro they're using. And that's always going to fail because certainly at any given time of the day, there's a certain part of the world that's asleep. People have automatic patching, but they don't tend to automate on a minute-by-minute basis. Also, it turns out that the patch was initially flawed, and there was in fact 6 other vulnerabilities in environment variable handling within Bash that all got the name sort of shell shock, and it took about a week to get all of these vulnerabilities fixed in all the different distros. And then over the next month or so, patches do get applied, and you know, the widespread worm, scans, abuse all sort of dies off. But this is something that follows the stock standard recommended disclosure practices, and you know, we don't actually know how many people got exploited across the internet, but it was a non-trivial amount. We don't know how much data gets stolen, etc. And it just goes to show that you can do disclosure with the best intention in recommended practices, but if the time it takes to write an exploit or reverse the patch is less than it takes to apply the patch, you're in trouble. All right, the other famous one, Heartbleed. So in April in 2014, within 2 days of each other, both Google and Codenomicon reported the same vulnerability. They scheduled a patch release date for about a week later, and what actually happened was 2 days before then, somebody decided to make a press release saying that, oh yeah, there was a vulnerability in OpenSSL, but we are patched, and they broke the embargo. There's also a lot of other potential concerns about the embargo and handling of this pre-release information within OpenSSL. Some companies got notified early, some Linux distros did not, etc. There's a lot of argument there. But the thing that I think we can focus on again is sort of patching. So at the time that the embargo broke on the 7th, Netcraft did a survey and said that there's about 500,000 servers with a valid certificate from a CA that are vulnerable to Heartbleed. 2 days later, Errata Security did a scan of the internet. They found 615,000 servers or IP addresses vulnerable, so obviously a lot of those didn't have valid certificates. They also found 330,000 that had Heartbleed enabled but didn't appear to be vulnerable, likely patched. And on one hand, I think that's good. Like within 2 days, we have 1/3 of the server code base have applied the patches. I'd like to see that higher, but yeah, it's not a bad start. However, the CA side of things was significantly slower. A couple of days later, only 30,000 of the 500,000 certificates had been reissued. A week after the initial embargo broke, there were press releases with official breach reports of companies getting breached through Heartbleed. Again, a month after, Netcraft does another press release. As it turns out, 43% of the CAs have been replaced. So less than half a month after. Furthermore, 7% of the certificates that had been replaced had not renewed their key. So the key that could have potentially been stolen through Heartbleed is still in use. So you renew the certificate, but the attacker who has the key can still just at will decrypt your traffic or perform man-in-the-middle attacks against your website. So very poor practices there as well. We moved on to June. At this point, Errata does another scan, 309,000. So at this stage, the bulk of servers have been patched. That's not too bad. It's 2 months later. We don't really have clarity as to how quickly those patches were applied, but there's still 1/3 of the server base almost is unpatched. Now, in January in 2017, Shodan did an initial press release, I guess, for this, and they found that almost 3 years after the vulnerability was disclosed, 200,000, or roughly 20% of the initial server base, was still vulnerable. So, this is a very high-profile vulnerability. You'd hope that patch adoption and remediation would have been faster, would have been, more widespread. But here we are, 3 years later, 20% is still vulnerable, and they would probably still be vulnerable even if the embargo hadn't broken and the disclosure had followed the intended path. But it sort of comes back to this notion that you can't fix vulnerabilities with disclosure. You have to fix it with patching. Similarly, I'll skip this one really quickly, Eternal Blue, because I know we're over. 2016, Microsoft said, please turn off SMB version 1, right, following bad luck. Then in March in 2017, they issued a patch for MS 17.0.10, aka Eternal Blue. A month after that, Shadow Brokers releases the exploit public. A month after that, WannaCry hits. So at that stage, you'd had 2 months of the patch being available, and Windows provides automatic updates. And you'd had 6 months of official advice saying turn off SMB version 1. If you'd listened to the security industry, you would have had years of warnings of turning off SMB version 1. And still, WannaCry hits, causes billions of dollars in damage. And, at the end of 2018, the estimate was still that there was millions of unpatched PCs. Here's a whole bunch of other stories. If you follow me on Twitter, you'll see me retweet these horror stories of dealing with vendors from vendors physically attacking security researchers at conferences, through bug bounty programs, refusing to pay out for valid vulnerabilities, through dodgy patching, through any number of things. It's not a solved problem, and I'll come back to the conclusion that it's not hard to find these, not every type of vulnerability at least, finding things like hard-coded credential in IoT devices, failure to validate SSL certificates, default credentials, weak password policies, any number of things like this is pretty easy to find. You don't have to be a super elite hacker to do this. Disclosure isn't binary, and what I mean by that is every vulnerability, every impact, every vendor, they're all different. You can't sort of have this is the right policy or this is the wrong policy. One policy suits all, right? I really feel that each vulnerability should be evaluated and disclosed in accordance to its own criticality. Omni's law, that's a pretty new thing, but it pops up every time Tavis Omni has a shower and releases a new vulnerability. He gets hassled on Twitter or other social media quite a lot by various people who don't like the fact that he's disclosed a vulnerability. And it's been proposed that we should have something officially called Omni's law, and the basis of Omni's law is that as a vendor, your allocated time for disclosure is directly inversely to the amount of time your staff spends harassing security researchers on the internet. I don't think we need Omni's law. I think overall we should all do better. I don't think that people will stop harassing security researchers, even though I wish they would. But people who aren't in this industry, I don't think will make good informed decisions on behalf of towards this industry. But I think bigger than the disclosure debate, we really need to work on secure code development whether you think that's shifting left, whether you think it's better frameworks, whether you think it's better tooling, it doesn't matter. I understand that some bugs will probably always still slip through, that's not a problem, and that's why we need to fix patching, right? Because eventually, you're gonna have to release a security update for your product, and you don't want to leave your users at risk. You really want the patch to be reliable, and you want the patch to come in quickly. And yeah, so that's it. I know we're out of time, so we're not going to do questions. I have a bunch of little koala things. If you catch me afterwards and you have a question, I'll give you a little koala from Australia. All right, thank you.